All right, for today's lesson, we are going to be on page 776, and we're going to kind of build off of what we did previously with our experiments of independent and dependent events. Remember, I said independent is something that is like individual, on its own, by itself. I am independent of my parents. What my mom and dad does not affect me. However, you are dependent. You depend on your parents. You rely on them, okay? To wash your clothes, to do your dishes, to cook your meals, all those sorts of things. So you guys are dependent, I am independent. So we're going to look at this first example that is independent events. So one letter tile is selected and the spinner is spun. So you can see here that the book drew out a tree diagram. So you have the options of choosing from your tiles. You have G, B, E, and A. Okay, so after you pick a tile, you're going to spin the spinner. Even if I picked G tile, I could still spin and land on A, B, or C. Even if I picked a B tile, I could still spin and land on A, B, or C. If I picked an E tile, A, B, or C, A tile, E, A, B, and C. Therefore, over here are all my sample spaces. Whoops. Oops. Technical difficulties. Maybe. There we go. Okay, so those are all of my sample spaces. Now, the question was, what is the probability that both will be a vowel? So I need to look over here at my sample space and decide how many of these are both vowels. Remember, vowels are A, E, I, O, and U. So here, G is not a vowel, so that one will not work. Neither of those are vowels. Neither are vowels. B is not a vowel, so that won't work. B, nope, nope. E and A are both vowels, so that one works. B is not a vowel. C is not a vowel. A and A are vowels, so that works. A, B, nope. A, C, no. So if you look at them, only 2 out of my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 options are vowels. I can reduce this fraction to get 1/6, which when I type it in my calculator and round to the nearest hundredth, I get 17 hundredths and 17%. Okay? Now, there's books going to show us another way that we could do this example, and this is going to be kind of relating to our fundamental counting principle. Okay, so if we think about it as how many options did you have for, I'm going to go back up and show you this way. Okay, so this is the second way. So if you look at here, how many options do you have for tiles? And you would say 4 times how many options here do you have on your spinner? And we would say 3. So 4 times 3 equals 12. There are 12 total outcomes. Okay? Now we have to think, how many ways can I get, how many options do I have in my tiles that are vowels? Well, E and A. So I have 2. Times, how many options do you have on your spinner that are vowels? I only have 1, A. So 2 times 1 is 2. Therefore, there are 2 out of the 12 total outcomes that would give me 2 vowels. And like we said, we could reduce it to 1/6, 17 hundredths, and 17%. So there's 2 different ways that we can solve them. Tree diagrams or using the fundamental counting principle. Let's see another example. So number 2 on the next page says the spinner and number cube, which is just a dice, are used in a game. What is the probability of a player not spinning blue and then rolling a 3 or 4? Well, since I have a lot of options on my dice and I have a lot of options on my spinner, I don't want to have to write out my tree diagram because it's going to get kind of big and messy. So I'm going to use the fundamental counting principle for this one. So first of all, I want to figure out my total possible outcomes. So I have a dice and I have a spinner. And I have 6 options on my dice total. and I have 5 options on my spinner total. Therefore, I have a possibility of 30 outcomes total. Okay? Now, I want to know specifically what the probability of a player not spinning blue and rolling a 3 or 4 is. Okay? So now I'm going to think of, on my dice, how many options do I have? I'm sorry, they used the spinner first. How many options on my spinner do I have that are blue? Sorry, let me start over. I'm messing this up. Of a player of not spinning blue and then rolling a 3 or 4. So if I look at my spinner, how many options do I have that are not blue? Well, yellow is not blue, green is not blue, red is not blue, purple is not blue. So I have 4 options that are not blue. Times rolling a 3 or 4. On the dice, how many options do you have that are 3 or 4? Well, I have 2, 3 or 4. So therefore, I have 4 times 2, which is 8. Therefore, there are 8 out of 30 options, which can be reduced by 2, which would give me 4 out of 15, which is what they got down here. Questions? All right, I want you to pause the video, try Got It A on your own first. Then when you're done, you can click play and it'll actually go through the answers. I do want you to try it on your own to start with. Okay, so a game requires players to roll number cubes to move the game pieces. The faces of the cubes are labeled 1 through 6, what is the probability of rolling a 2 or 4 on the first number, and then rolling a 5 on the second. Okay, so I'm going to figure out my total first. So roll 1 and roll 2. So on roll 1, I have 6 options, 1 through 6. On roll 2, I still have 6 options, 1 through 6. Therefore, I have 36 total options. Okay, we're trying to figure out what the probability of rolling a 2 or 4 on the first number cube and then rolling a 5 on the second. So this time on roll 1, I have the option of a 2 or 4. And there are 2 options on a dice that are 2 or 4. Times, on roll number 2, I only want to select a 5. So there's only one option on a dice that is 5. Therefore, 2 times 1 is 2. And there are 2 out of 36 options for that probability. I could reduce by 2, and I would get 1 over 18. And I could type that into my calculator to get my decimal and percent. So 1 divided by 18. I get a repeating digit, so I would round to the nearest hundred and get 56 hundredths and 56%. All right, you're going to stop this video and you're going to go back to your choice board to see what your next assignment is or task is.